Hello everyone. Today let's solve the problem Alyona and the tree. Right. So this was asked in the Codeforces round 358 division 2. Right. So I can just go through the question. It's very easy to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Right. So what the question states here, we have a rooted tree. Right. So just give me a second. 1 second here. 1 second. Yeah. Just give me a second here. Yeah. We have a rooted tree. So root, this is first initially the value will be 1 basically, right? So we have a rooted tree, root equals 1. Each node u has value a of u, right? See here, each node u has the value a of u. Just remember this, right? So each edge has weight c. Each edge has what it has? It has weight c, right? So a vertex v is sad if some u in v subtree has distance u comma v is greater than a of u. Again, a vertex v, this one vertex v, nothing but the edge, is sad if some u in v subtree has distance of v comma u, this one distance of v comma u is greater than a of u, is greater than a of u. Just remember this one, right? So Alyona repeatedly removes leaves until no sad vertex remains, right? So what does Alyona do here? Alyona repeatedly removes leaves until no sad vertex remains here. We have to output the minimum number of leaves removed, right? So we have to output the minimum number of leaves that has been removed, right? So that's what we need to do. Again, let me repeat the this one, what do we call question once. Just listen to this carefully. So we have a rooted tree where initially root equals 1, right? Always remember this. Each node u has the value a of u and each edge has the weight c. We know this, fine. A vertex v is sad, a vertex or the edge v is sad if some u in v subtree has distance of v comma u is greater than a of u, this one, right? So if it is v, the vertex v is said to be sad if u in v subtree has distance of u v comma u is greater than a of u. Nothing but in simple sentence, sum of the edge weights from v to u basically, right? So Alyona repeatedly removes leaves until no sad vertex remains, right? So Alyona will repeatedly remove the leaves until no sad vertex remains actually, right? So that's what he does. Now we have to output the minimum number of leaves that has been removed, right? Nothing but it is equivalently total nodes removed, right? So we have to count the total nodes removed actually in simple sentence, right? So we have to output the minimum number of leaves that has been removed. Just keep this in mind. I hope the question part is completely clear, man. Let me remove this one. Let me delete this one basically. Now we have value this one actually, right? So we have value this one. So the number of minimum number of leaves that has been removed or the total nodes that has been removed is equivalent to the 5 basically. They have showed the same thing here. See, overall it will be 5 basically, right? So the output will be 5. 5, this one will be removed, right? You can just go through the this one, what do you call, diagram, right? They have given us wonderful this one diagram just for the sake of understanding, right? So you can just pause this one and take a look into it, and again this one as well, 4 5 6, right? So we are left with basically 5, right? So I hope the question and input output part is completely clear, man. Let's do one thing. Let's quickly discuss the approach followed by the complexities and then let's write the code. First, let's discuss the approach first. So here I have considered the same first example that they have given in the question. We have already discussed this one. The output that we need to get here is 5. We know this one, right? So let's move on with the step-by-step explanation. Before moving on with the step-by-step explanation, let me tell you one thing. So we will be making use of the dynamic programming to solve this particular problem, right? So we'll be going with dynamic programming along with this one, DFS basically, right? So let's see the approach. Let's discuss the approach first, right? So just give me a second here. This is fine. And let's move on with the step-by-step explanation. First one, let's discuss the DP idea. So while I said we'll be making use of the DFS as well, right? While DFSing from the root, we will be maintaining the DP of u. That is nothing but the maximum excess distance so far along the path. Just remember this one, this part. Just try to remember this part, right? So while DFSing from the route, we will maintain dp of u equals maximum excess distance so far along the path, right? So when going to a child with edge weight w, will pass next equals this one as well, max of 0 comma dp of u plus w. This is accordingly with the question, right? So if dp of u is greater than a of u, right, a of u, the node is already sad, right? So we will prune its whole subtree, right? So if dp of u, this one, just remember this one, this is very important. If dp of u is greater than a of u, the node is already sad and we will prune its whole subtree. Let's see the same thing further, right? Let's go with the sample here. Root 1 dp equals 0, we have less than or equal to a1 88. The first one we are considering here within the input 88, this one, right? This one, so we will keep this one. So we will be keeping this one because 0 is quite obviously less than or equal to 88, right here. So we are comparing 0 less than or equal to 88. Yes, it is, right? So we will keep this one. Let's go with the edge. Now we have 1, right? So 1, next value that we have here is we'll be going with the 67, this one. We'll keep the, we are going with the first edge, right? So we will be going with a 160 1 4 comma 67, right? 4 comma 67. So child 4 dp equals 67, right? So dp equals, we have to check whether 67 is greater than a4 because we are going with the child 4. A4 is nothing but we have 14, I think, value, right? So this one, see here, a4, a1, a2, this one a3, a4. So this one I'll write it over here, A5, A6, A7, A8, A9. This is fine. We are checking for A4. A4 we have the value 14, right? So now we are checking whether 67 is greater than 14 or not, right? 67 has to be actually less than 14. So this one dp part has to be less than actually 14. Dp we have the value 67. This 67 has to be less than 14 basically, but it is 67 is greater than the value 14, right? So here 67 is greater than value 14. So this fails. This miserably fails. This is sad. We will prune 4. What we will do, we will prune 4 as we are going with the child 4. We will prune 4, right? So next we will be going with a we are going with one after the other edge, right? So now this one, we are going with the 1 first, basically starting with the 1, right, edge 1. So now we will be going with this one, 164, right? So here, let me come here. Yeah, this one will be child this one, child 5 basically, right? So child 5. So we will be going with 1 to 5 comma 64, 1 to 5 comma 64, right? So this is fine. Now this is in between this one, right? What do you call 14 and 95? 64 is in between 14 and 95, right? So this one is 64 basically. 64 is in between 19 and what do we call, so other value was given here, 14 and 95 basically, sorry. Yeah, so what we will do, we'll check whether 64 is less than or equal to 95. 64 is less than or equal to 95. We have A5 95 here, right? So this, what do we call, 64 comes between 14 and 95, right? So we will check whether 64 is less than or equal to 95. Yes, 64 is less than 95, right? So we will keep this one. We will keep this one. This is fine. This is good, right? So this is fine. Next we will be going with we are done with 1, I think. We are done with 1. Next we'll be going with 5 basically, right? So next we will be going with 5. Just give me a second here. Yeah, next we'll be going with 5, right? So 5 to 7 comma 12, 5 to 7 comma 12. So this is for the child 7 basically, right? So we have 12 basically. Just give me a second. Mm, 1 second. Yeah, so here we'll be going with a value 76, right? We'll be going with a value 76. This one we have mm, 80. Yeah, this is fine. We'll be going with 76, which is less than or equal to 98. A7 we have 98 here. A7 value 98. So we will this one A7 we have 98. So we will check whether this one what do we call 76 is less than or equal to 98. Yes, 76 is less than 98, right? Less than 98 and the 76 is less than 98, so again we will keep same. We'll do with the for 7 as well. 7 3 comma minus 8, so this one will be 68. 68 will check with the a3, this one 3, right? So child 3 basically. Now what we'll do, we'll check whether 68 is less than or equal to 83. 68 less than or equal to 83, yes it is, right? So then again we will be keeping this one, right? So this is fine. Next, we will go with 3 to 2 comma 24. Child 2 will be considering here. So we will check whether 92 is less than or equal to 22. A2 value is 22 here, if I remember. This one we are considering, right? So this is fine. 92 is less than or equal to 22. No, 92 is greater, right? So 92 is basically greater than 22. This fails basically. This is sad, and we will prune this one. Prune child 2 basically. 2 to 24. Yeah, 2 comma 24 we have given, right? So next we'll go with 3 to 9 comma 8. This one, right? So DP value is 76. So 76, we'll check whether 76 is less than or equal to 11. No, 76 is greater than 11, right? So here in this case, what we will do, again, this is sad, and what we'll do basically, this one, we will prune 9 as well. We will be pruning 9 and its subtree along with its subtree accordingly with the this one approach that we discussed earlier, right? So DP idea. So if you remember, right? So this will be 9 6 comma 65. This is pruned with 9. Basically this is nothing but we are pruning with the subtree, right? So you can just look into it. 6 to 8 comma minus 80 pruned with 9. 9 to 6 comma 65, 8 to 6 to 80. This one and this one we are speaking of. 5 and 12 we are already done. This part is already done basically, right? So this is fine. We are almost done. So what are the notes that we'll be keeping here basically? What are the notes we are keeping basically here? Just give me a second here. uh, this one, one we will go with. So one a1. So this one a7 will be going with, we'll keep a1. This one a5 nothing but 5. 1 comma 5. This one will keep, this one is 7, a7, and this one also will keep, this one is 3, right? So 1 5 7 and 3 we will keep basically, right? But yeah, 1 5 7 and 3, right? So this will be equivalent to the 4 basically, right? So 1753. So this is 4. 4 means the number of nodes actually 15734. So total we have 9. We will be going with the kept nodes minus 9 minus kept nodes, right? So 9 minus 4 we will get output 5 basically, right? So output that we got here is 5, which is equivalent to the output that they have mentioned for the this one. What do we call? This is done as well. What do we call the output 5. The output that we got here is 5, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So our approach works absolutely correct in this case. So right, our approach works absolutely correct in this case. So now as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities and the let's quickly discuss the complexities part, right? So what will be the time complexity? The time complexity would be big of n. When I said the time complexity is big of n, each node or edge processed exactly once with a constant time dp transition here. So overall time complexity would lead to big of n, right? So this is fine. Here the space complexity would be big of n as well, because we'll be going with the adjacency lists as well as the dp array and the recursion stack, right? So overall space complexity would lead to big of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n for both respectively, right? So this is fine. Now as we are completely familiar with the approach and complexities, we are good to write the code. Let's start writing the code. Let's start writing the code. I'll just come to the compiler now. I'll just do one thing. Let me go with import. So let me import the input output package, man. So this is fine. Now let me do one thing. I'll just go with java.util.star. So this is fine. Now let's do one thing. Let me go with public class. So this one, let me go with main. So I can just go with any class name. So I'll just go with main, right? So basically go with the class name something that is relevant to this particular problem, right? So first let's go with the number of vertices, input output, but basically, so I'll just go with static int n. And also we know that a of u is nothing but the node limits, and dp of u is nothing but running excess distance at u. We have discussed this one within the approach, right? So I'll just give here static long. So this one a comma dp. This is fine. Again, let's go with the adjacency, right? So we have to build the adjacent, this one adjacent list, right? So I'll just go with static here. This one is fine, and this one is list. This is fine. So this one will be int. Yeah, this is completely fine, man. G. This is fine. Next thing is let's count. Let's go with the count of non-sad nodes that is being kept. So I'll just go with static here. This one int count. Let's initialize this one to 0. Right. So let's go with the main. So this one, let's go with the main method, right? So let me delete this one. Here, let's do one thing. Let's go with the fast input reader, man. So this one will be fast scanner. So this is fine. This one will be fs, that is equal to new fast scanner. So this one is nothing but we'll be writing this one. Let's do one thing. Let me copy paste this one. This is completely related to the fast input one, right? So this is not at all relevant to the logical part. So this is completely this one related to the input output part. So I'll just copy paste that one. Just give me a second here. So let me come here. Sorry, 1 second. So let me do one thing. Uh, I'll just paste this one. This is nothing but the fast scanner class, right? So this is related to the input output. So I just didn't want to type this one. This is completely related to the input output part. So let's move on with the further things. Now within the main method, we need to read n, right? So if you read this one, we need to read n first. So I'll just go with n equals fs dot next int. So this is fine. Yep, this is correct. Next, we have to allocate a of 0 to n minus 1. So I'll just go with a equals new long of n. This is fine. Now let me go with a for loop here. This one will be int I equals 0, uh, I less than n, and this one will be I plus plus. So this is fine. So this will be iterated value of the a is nothing but the fs dot next. So I'll just go with the next long here. This is fine. So we are just reading all the iterated value of the a, or a of I here. We are just reading all a of I. This is fine. So this is fine, man. Next, let's do one thing. We have to build the adjacency list accordingly with the approach. So I'll just go with the variable g equals here new array list. So this is the syntax. This is fine. Now let's go with the empty list per node initially. So let me go with the iteration part here. This will be I equals 0, I less than n. So this will be I plus plus. So this is fine. G dot add. So this one will be new array list. So this is fine. This is fine. Now this is fine, man. Next, we will be going with the input format for I equals 1 to n minus 1. We will be reading the parent p of the node I plus 1 and edge weight c, right? So let me go with the for loop here. This one will be int I equals 1, I less than n. So this one will be I plus plus, right? So within the for loop, so we'll be going with the parent nothing but 0 based. So this one will be int pay equals, so fs dot next int. So this one will be next int minus 1. So this is fine. So we'll be going with the edge weight. So this one will be long c equals fs dot next int. This is fine. This one will be next long. So this is fine, man. So we are going with the edge weight. The final thing here would be we have to add the directed edge, nothing but p to I with the weight c. So accordingly with the approach that we discussed. So this one will be, I'll be making use of get here dot p. So this is fine. So I'll just go with add. So this one will be new int. So this is fine as well. Now this one is I, comma this one is int. So this is fine. This one is C. Uh, this is fine, man. Yeah, I'll just come out of this one entirely. Now, let's do one thing. Let's go with DP array. So I'll just go with DP equals new long of, and this is fine. Let's start the DFS at the root 0, right? So before starting the DFS at root 0, we have to go with the DFS function, right? First, let's do that. So let me, for this one, I'll just go with here this one static what DFS method basically, right? So DFS, so this one will be into comma and p and also long sum. So this is fine. So within the DFS method, let's do one thing. Let's record the DP at u. Means here I'll just go with DP of u equals sum. So this is fine. Next, uh, if u is already set, then we have to prune entire subtree. This one we saw this within the approach, right? So we have to articulate the same thing in the form of code. So this one will be if dp of u, if it is greater than a of u, then we have to return, right? So this is fine. Now what we need to do here, u is kept. Basically u is not sad. If u is not sad, then we have to count it. Means we have to increment the count. I have considered cnt right here. So let me increment cnt variable here. This is fine. Next, let's explore the children as well, right? So I'll just go with the for loop here. This is fine. This one will be e g dot get of u. This is fine. So within the for loop, let's do one thing. Let's go with the child index and edge weight, right? So this one will be int v equals e of 0. This one w equals e of 1, right? So this is fine. So we are going with the child index and edge weight, right? So now let's do one thing. We have to go with the this one transition, nothing but if current dp of u is negative, the best ancestor to start from resets to be here, right? This one we have to consider, and also the next dp for the child, that is equal to max of 0 comma dp of u plus v. So we are just going with a this one classic path access dp for this particular problem, right? So I'll just go with the recurse part here, dfs of v comma u comma mat dot max here. So this one will be 0 comma dp of u. This one is fine. dp of u plus what we need to do, plus w, right? So this is fine. Now we are done with the, we are done almost, right? So with the coding part. So now let's do one thing. So we are done with the DFS part, right? So now we can make use of the DFS helper method within the main method. So I'll just call the DFS method here, helper method here. So this one we have to start the DFS at root 0 parent -1. Parent has to be -1 initially, right? And also we'll be going with the initial dp sum, that is 0, right? So basically 0 -1 and 0, right? So I'll just go with 0 -1 and 0. This is fine. Finally we have to output the result. So we are just going with the fast input here. I'll just make use of the system out println, nothing but I'll just go with let me give here println. So this one will be n minus count. So this is fine. Yep. So this is removed equals total minus kept, right? So this is removed equals total minus kept, nothing but n minus count here in this case, in the terms of the coding, right? So we can just write here n minus count, right? So this is fine. Now we are done with the coding part one. So what shall we do now? I'll just come here. So before checking the code with different inputs, let me copy paste the signature starter template, right? So just give me a second here. So let me come here. So let me paste this one. So this is fine. Now we are done with the coding part. So I'll just come to the question. Let's check the same thing. We have only this one input, right? So totally we have to get the output 5. We have discussed the same thing within the approach as well. Let me paste it over here. Let me run this one. The output that we need to get here is 5. Yeah, we are getting the output 5. So the code works absolutely correct in this case. So let me copy this one entirely. So let me come here, let me click on the submit button, and let's do one thing. Let me come to the submission part, and let me copy paste this one, sorry, paste this one. Let me hit the submit button. I hope this works for all the test cases, man. Let's see. Let's wait for some time. So running on the test one, let's wait for some time. So I can clearly see they're running on test 6 actually. This will take a while. Let's wait for some time. This is slow, man. So for this particular problem, we have just made use of the pure DP, right? Pure DP as well as the DFS, depth first search, right? So this will be very helpful. A DFS is very helpful for this particular problem along with the DP basically, right? So simple one. This is fine. So we can go with the simple problems initially, then we can just go with a bit mask DP on the trees as well. Then let's go with some hard problems, DP hard problems, and then we can just explore the other problems as well, right? So first we are going with just the simple problems currently. As I've said, next we'll be going with a next let's go with bitmask DP, and then we can just go with the DP on trees as well, then some hard problems, and then finally let's explore what is left, right? So that we can do. Let's go step by step. No worries, we have enough time, right? We don't have to rush. Still running on test 73. How many test cases are there, man? um, let's wait for some time. The only thing that I have copy pasted here is this one, man. This is purely related to the input output, right? So this is not at all related to the logical part. So that is the reason I copy pasted this one, right? So just ignore this one. You can just go with any template or any input output template. It doesn't matter. So go with a one that you understand better, right? So if you're giving the contest, and if you are going with the binary and all the completely this one, what do we call, you are completely going with a buffered input and this one, that is fine. If it is completely understandable, right? So for I have some around 10 to 15 templates, so that I make use of, right? So you can just go with any one of your choice. I don't care, but go with the one while you are solving the problem, or while you are practicing, go with the one that you understand, right? That you understand better. Even try to understand the input output along with the, this one, what do you call, logic, when you are practicing, I mean. So here you can clearly see the verdict that we got here is accepted, means whatever the code that we have written works absolutely correct for all the test cases, right? So this is pure DP plus DFS, right? So pure DP plus DFS basically, right? So DFS also helps a lot here basically, right? So we are done with the this one solution part basically. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.